The next thing that we're going to be looking at is overlapping events. And these are going to be events that where they're going to share something that's going to be identical. So events that have one or more elements in common. So an example of that would be if you were pulling out of a deck of cards all aces and all diamonds. And if you know anything about a deck of cards, there are aces, there are diamonds, and one of those cards is both an ace and a diamond. So there's one card that has an element that's being shared, that they are both an ace and a diamond at the same time. So the diagram is going to look like this. You have your universal set, and you have your A event and your B event, and you're going to have this intersection. Now, we've already seen something like this before when we were talking about intersection, so you guys have seen this once before. Now, the overlapping probability, it's also known as the addition rule, and this is how we can find the probability. I'm going to give you an equation, and it's a lot to look at, so just be patient with me. This is probably the simplified way to look at it. You're going to take your probability of A plus your probability of B minus what is going to be the intersection, or the number of elements that they're sharing. Another way to look at this, these are the symbols that we've actually used for this. The probability of finding a union is taking the probability of your A and your B and subtracting the intersection. But here it is, and probably the way that you guys will be using it the most. You're going to take the number of elements in your A divided by the number of elements in the set plus the number of elements in B divided by the number in the set, and then you're going to subtract what they are both sharing, the number of elements that they share, and divided by the number in your set. And so that is going to be how we find the probability in our next example. With our example, you shuffle a standard deck of playing cards and choose a card at random. So you don't have any jokers or anything like that in there, but we want to know what is the probability that you choose a king or a heart. And so first we've got to set up our numbers. We need to know how many is in our set. So we know that we're playing with a deck of cards, and in a deck of cards there are always going to be 52 cards. So pretty much whenever you're playing with cards, probably your set is going to be 52. The next thing is the number that's in our first event. So what is the probability that you choose a king? That's going to be our first event. So we have to ask ourselves, how many kings are in a deck of cards? And if you know anything about a deck of cards, there are 4 kings in a deck of cards. So that's going to be the number in our event. And then in our second event is what is the probability that you choose a heart? So that's going to be our second event. So we're going to figure out how many hearts are in a deck of cards. And there are actually 13 hearts in a deck of cards. So that's going to be our second event. And then our final thing that we have to ask ourselves, is there a card that is a king and a heart? And actually there is. There's only one card that is a king and a heart. So the number of A and B, or the number that's in both of those, is 1. There's one card that is a king and a heart. So we're going to put in 1. So then from here on out, we're going to use this equation right here. So we're going to use the probability of A or B, and I'm just going to fill in the right pieces in the right spots. So the number for A, instead of saying the number for A, we're going to say 4. That's how many elements are in our A event. And then the number that's in our set is 52 cards. Plus the number that's in our B, so that's going to be 13. There's 13 hearts, divided by 52, minus the number in both A and B. So that's going to be this number that's both in A and B. So that's going to be minus 1 over, once again, n of s, or 52. Once again, the 52, because it's the same all the way across, I'm going to write it all the way across as 52 again. It's a common denominator. And then I'm going to say to myself, 4 plus 13, that's 17. 17 minus 1 is 16. So I'm going to write 16 here. And if I can simplify, I will do that. And I can simplify it. 2 will go into both of these. 2 will go into 16 8 times. And 2 will go into 52 26 times. I can actually simplify this even more. 2 will also go into 8 and 26. 2 will go into 8 4 times. And 2 will go into 26 13 times. That is now simplified to the most that it can be. So ultimately what we have here is the probability of being able to pull out a king or a heart. You have a 16 and 52 chance. In other words, a 4 and 13 chance, or a 4 and 13 probability.